Hello everyone and welcome to today's episode of Farm Business Options. My name is Barry Caslin, Teagasc Energy and Rural Development Specialist, and the aim of Farm Business Options is to give landowners thinking of diversifying their income a good understanding of how to turn an idea into a viable business and to look at new business development opportunities. Today's topic is the area of the digitalization of agriculture and new technologies. This webinar is recorded and there is a chat function there at the bottom, so if you have any questions for our panelists, you can ask those questions via the chat function. Today's panelists include two of my colleagues, Anya Regan from Teagasc and Athenry, and Stuart Green from Teagasc Ashtown, and we have Peter McShane from GLAS Energy Technology. The format of this is generally how we have is that each of our panelists will give a short presentation about their area of work and opportunities they see in the whole area of digitalization within agriculture. And after the three of them have spoken, we will take your questions and any questions that I may have as well for our panelists to tease out the topic even further. So without further ado, I will introduce our first panelist, who is Anya Regan. Anya, you're very welcome today. How are you?
Thanks, Barry. I'm doing good.
Good to have you here today. Anya is a research officer in behavioural and social science with Teagasc. Her research in digital agriculture looks at the process of how new technologies are developed and governed with the end user in mind. Other areas of work currently include behavioural change and responsible antibiotic use in agriculture and public perception of food and farming. Anya has a degree in psychology, a master's in health psychology, and a PhD specialising in risk communication in food and agriculture. So Anya, you're going to give us a short talk about some of those areas of work, especially on the area of digitalization in agriculture. I know you've spoken widely about this, not only in Ireland, but abroad as well. So if you want to share your screen with us there, Anya, and you can you can do your short 7-minute presentation. I'm going to turn off my camera there and allow you to talk there. You can go into presenter mode.
Great, thanks, Barry. And just to double check, you can see my presentation okay there?
Yes, everything's good there. Thanks.
Great, thanks, Barry. Great, so as Barry mentioned there, my research interests are to look at things from a more behavioural perspective. So I'm going to give an overview of digital technologies for Irish farmers from the perspective of how do we best develop and govern digital technologies with the end user in mind. And the end user in this case, of course, is Irish farmers. So when we talk about digital technologies, first of all, we're talking about quite advanced technologies, I suppose, like sensors, drones, satellites, robotics, smartphones, and so on. And what's common across all these technologies is that they're all generating and collecting data about the farm and how it's performing. And the idea there is that that data allows the farmer to take out the guesswork of decisions and make more informed and evidence-based decisions. So we are seeing an increase in the use of these technologies on our Irish farms, but uptake isn't consistent across all farms. So a recent study from the IFA and the Farm Business Skill Net found that 46% of farmers who participated in their survey were using some form of technology on their farm. So if we look at how that breaks down across different types of technologies and different sectors, we can see, first of all, that smartphone ownership is very high, but that does come with a caveat, I suppose, that smartphones tend to be mainly used for checking weather, news, and livestock prices. And I suppose the use of smartphones for more kind of digitally sophisticated apps tended to be quite low. So some of the more frequently used technologies then included calf registration systems, camera monitoring in barns, herd management systems, and remedy recording systems. And what we see here as we look across the sectors as well is that dairy and tillage sectors tended to have the highest rates of technology adoption. So what this sort of picture tells us is that we do have quite significant numbers of farmers who are not engaging with different technologies. So one of the things that we do in our research is look at why that is. So very simply, we can look at this model, which argues that if a person, a farmer, is going to use a technology, they have to have the capability, the motivation, and the opportunity to use that technology. So in this example, barriers that could stand in the way of having capability would include, for example, farmers not having the knowledge or the skills to use the technology. Factors that could prevent motivation could include a lack of awareness, a lack of a belief in the benefits of the technology for themselves, and mistrust in the technology provider, and perhaps mistrust about how their data will be used. And a really big one that comes out of the research is feeling a lack of confidence to use technology. Then we have opportunity, and these are usually factors that lie outside of the control of the farmer. So for example, issues around cost, infrastructure, access, internet access, social support, and the way the technology itself has been developed. So exploring the barriers using a model like this is really helpful because it breaks down all the possible factors that could be preventing engagement and then allows us as researchers to address them in a much more targeted way. So ideally, we don't want to be finding these issues out after a technology has been developed. We want to find these problems out long before the technology has been designed or built at all. And that's why we encourage a particular way of design and technology called user-centered design or design thinking. And I want to give you an example from a project we're involved in at the minute with the Department of Agriculture and technology developers from TSSG and Waterfront IT. So basically the context of this technology, which is a geotagged photo app, is when a farmer is applying for particular schemes. Say the department has a query about a parcel of land and may need to get visual verification of that land parcel. At the minute, what happens is a department inspector goes out to visit the farm, which is time consuming and an administrative burden for both the department and for farmers. And what we've been exploring within the NEVA project is the technical development of a geotagged photo app, which would eliminate the need for these farm visits and instead allow farmers to use their smartphone or tablet to take photographs of the land parcel and upload those photos onto this app. So with this technology, we employed a design thinking approach to develop the technology itself. What this basically means is involving the end users of the technology in the technology design process. So before the technology is actually designed, we talk to farmers, to farm advisors and to farm inspectors, and then we kept talking to them throughout the design of the technology. So this allows a really iterative approach to technology development where we were identifying the needs of the farmers and farm advisors at an early stage, identifying possible barriers that could come up in an early stage, and then most importantly, identifying solutions that the users themselves came up with and integrating those solutions into the design of the technology. So what this does is it makes sure that the technology developers aren't making any assumptions about what it is that the end users need and want. And it also triggers different and more creative ways of thinking about what the technology can actually look like. So this app is called AgriSnap, and it's currently in a second testing phase. And if anyone would like to take part, this is very much an open invitation. And I would definitely encourage you, if you're a scheme applicant, to drop us an email if you are interested in taking part in the test. So a challenge we talked about earlier as well is the lack of trust that farmers might have in technology providers because of what might happen to their data. And on its own, your data is really only useful to you and your farm. But when your data is combined with the data of lots of other farms, then this big data can become very valuable for various different third parties. So we carried out a series of workshops with farmers exploring what they thought about this issue of data sharing. And a number of concerns did emerge from those workshops around who owns the data, is farm data the same as personal data, and that idea that if third parties want access to data, what happens and who should decide whether they get access. So again, there's lots of different initiatives that are underway to try and address these issues. And we're working on a project at the minute that is, again, running workshops to hear from different people on this issue of data ownership. And in our next series of workshops, we're going to be actually testing the concept of a multi-sided data governance platform, which would try and give a little bit more control back to the farmer around what's done with their data. Again, this is very much an open invitation. So if anyone is interested in taking part, feel free to drop us an email and we can give you more information on that. My final slide I suppose, is more maybe one for a bit of a discussion, but it is the idea, I think, that it's interesting to think about how COVID-19 might have prompted some farmers into an online and digital environment. So we're seeing a lot of companies now facilitating marts to go online. We have farmers who have moved from buying their farmer's journal in the shop to now having online subscriptions and reading the journal on the iPad. We have discussion groups moving to Zoom. We have farmers relying more and more on social media like WhatsApp and Twitter to keep in contact with other farmers. And I suppose more broadly, we have seen, some farms and food producers who potentially maybe are operating in smaller food supply chains move into online digital markets. So there has been a lot of change. And I think it is interesting to think about how positive digital experiences during COVID-19 may have had the impact of improving confidence amongst farmers and allowing them to realise the potential of increased digitalisation on their farms. It's also interesting to think about post-COVID, when we are hopefully in the not too far future, when we're restriction free. Do we want to go back to what we had before, or are there certain elements of digitalisation brought on by COVID that we want to keep? And also, how do we ensure a good balance of digital and non-digital to ensure that nobody is left behind? So that's it from me. Thank you very much, and happy to take a question now, or leaving it till later.
That's great, Anya. Thanks very much for that great presentation. And very interesting to hear your last slide about the farmer adoption rate as well, because of COVID-19. And I can relate to that myself, because my own father is almost 80 years of age, and he's actually reading the Farmer's Journal online for the first time. He's looking at the Independent newspaper online as well. And he's also looking at the marts, much to my mother's disappointment, watching the marts online as well, creating a lot of noise in the kitchen. So I think we are seeing a massive change or move towards digital and acceptance by older generations as well. Just in relation to millennial farmers, are they really challenging Teagasc at the moment, Anya? Do you think that that they're more digitally equipped, they're far more literate, and maybe and better able to interact with these new technologies? Do you find this a challenge for Teagasc at the moment?
Yeah, I definitely think younger farmers obviously are a little bit more, they have more self-efficacy when it comes to digital technologies. And to be honest, one of the big challenges, I think, is increasing what we call digital self-efficacy, our confidence to use technologies. And that doesn't seem to be an issue with younger farmers, but certainly with older farmers, they do need a lot more support. And I suppose even with the example of the NEVA app, the AgriSnap app, one of the things we did find early on was this idea that some farmers who wouldn't be comfortable using smartphones or tablets would, ask for a nominee to do it on their behalf. So this could be farm advisors, or it could be a relation, for example. So what that does, I suppose, is it does put more pressure on the role of the farm advisor, that they have to be digitally equipped as well, and that they have to have good confidence and skills around digital technologies. But there are a lot of initiatives to help farm advisors as well. So there is a project called Fair Share that Teagasc is leading. It's a large European project, and it is very much in the space of supporting farm advisors to adopt digital technologies and digital advisory services. So, there are a lot of, I think, helpful initiatives out there, and it's just a matter of bringing people into those types of initiatives and help train them up.
Yeah, I think Fair Share is quite interesting as well, that it's actually looking at digital technologies, not just in Ireland, but across Europe. So sometimes we can be replicating stuff that's already done in other countries, and maybe taking that knowledge and using it here as well. So it is quite interesting, those projects that you mentioned, and we can talk about those after a while. And as I say, if anybody has a question for Anya or any of our panelists, just at the bottom of your screen there is a chat function, and you can put the question to Anya or Stuart or Peter there. Our next speaker is also a colleague of mine from Teagasc, Stuart Green. Stuart is a Senior Research Officer at Teagasc based in Ashtown. He's specialist in satellite mapping of the agri-environment in the Department of Agribusiness and Spatial Analysis. He's been working for 20 years in mapping soils, environment, grass production and hedgerows using satellites and drones. Some of the department's work can be seen each month in the Teagasc map of the month. So Stuart, great to have you here today. How are you?
I'm good, Barry. Thanks.
Yeah, great to have you, Stuart. And you have your presentation ready to go. So we'll go on mute, and we'll turn off our videos, and we'll come back to you at the end of your talk. Thanks, Stuart.
Thanks, Barry. Hi, I'm going to talk this morning quickly about sort of digital information tools for farmers. So I'm not going to be talking about the hardware, the robots, the tractors, and so on. Just the sort of apps and online services that you can access to help your business. There's a lot of them around. There's been a number of projects in the last 2 years trying to list all these things. Fair share has just been mentioned, but there's literally hundreds and hundreds of tools. You can go to these websites. These slides will be up afterwards, and you can search to find a tool in a certain area. And a lot of them are free or testing, or so you can get access to them. We've all been digital for quite a long while, even if we don't realize it. And the first bit of digital has been, information on the farm business. So things like the Teagasc e-profit monitor, commercial services like HerdWatch. These are all digital assets on the farm. Coming down the line is more detailed information on your farm, things like digital asset management, controlling stock and buildings and equipment. Issues around what's called building information models, and these are how modern buildings are managed to improve heating, lighting, and cost management. And this sort of model is coming into the bigger agricultural concerns, mostly in horticulture at the moment, but it is moving down to the idea of BIM for agriculture. And then another big thing that's going down the line is this idea of blockchain in the supply chain. So if you're looking at your farm to fork traceability, blockchain is the technology, a digital technology that means that essentially the figures can't be altered. It's sort of impervious to outside interference. So it increases confidence in both the farmer and the supplier and the consumer. Again, most farmers will be well used to the idea of mapping their farm under the LIPIS and the CAP system of old. This has been done more and more. Lots of people are getting their farm surveyed in terms of restructuring the farm. It can be important, I think, going forward to get essentially a baseline of where your farm is now. It can act as an evidence-based in case you're challenged in the future over some breach of regulation or rule base. Lots of companies will do this. I mean, there's dozens and dozens, some particularly high-tech ones that look at measuring and monitoring and mapping assets, things like FarmEye, Anya, which I'll talk about in a few minutes, Grasshopper, which is linked to the Teagasc pasture base, AgriNet, and then of course the Teagasc NMP Online surface. So all these use a map, a digital map of the farm to tell the authorities or the farmer about the farm environment. I just want to say that don't forget the farm is a three-dimensional thing. A lot of places now are getting surveys done by drones, and they're great pictures. They can give very accurate maps and so on. But if you're doing that, I'd encourage you to get a 3D model made from these pictures. It's a trivial thing for a good surveyor to do. It's 95% automated. It shouldn't add too much to a cost of getting a survey done. And what it does is, it gives you a three-dimensional reference for where your farm is now, but it's also really useful if you're planning new farm roads, if you're planning new farm buildings, if you want to know the carbon store in your hedgerows, where hedgerows and trees are, if you want to look at runoff. It's a really valuable asset to get, a digital asset to get for your farm. And then, of course, we have what's known as the Internet of Things. These are sort of sensors in the ground. We have a number of Irish companies. A few examples are Anya with their soil and grass sensors. Then on the animal, you have Dairy Master with the Moo Monitor. Lots of farmers are investing in weather stations, and there are different stations of different complexities and linkages with different systems. An interesting example across Europe I came across is a company called New Republic in Greece, have what's known as the GLAS system, and you don't pay for these objects or these sensors. You pay for the services that come from them, so there's no big outlay. So now this company has scores of these sensors around Greece, and of course every time a new sensor goes in, the value of the entire model goes up, so that each farmer gets more. So it's an interesting model. You don't need to be paying big outlay for the hardware. You pay for the service, the value you get. And then we're looking at services that give you information on farm production. And this is where I've been spending a lot of my time in the last 10 years, is using satellites and drones to look at farm covers, farm growth, grass growth, crop stages, soil properties. And there are lots of commercial companies The big Irish company Origin has got a number of these services, mostly based in the UK, but they do spill over into Ireland. There's a big project underway from UCD with Origin called Consus, which again is looking at these satellite-based systems to tell the farmers about nutrient needs, losses in production. And then of course we have the Teagasc pasture base, which is a big online system that allows farmers to record all the information on production. Talking about GLAS, most of these systems, these satellite systems, have been designed for croplands, but there are, I found, about 20, 25 systems that are designed for grasslands. And here's a couple at the bottom there, a couple of examples down in Australia, which do provide a service in Ireland, which give you biomass on your paddocks from satellites, and they can give you covers and so on, and automatically calculate grass wedges or feed wedges, as they call them. So all this technology is there. None of it's been tested in Ireland. We're producing our own versions, our own research in Teagasc. So I'm not giving any sort of handout to these companies or saying you should use them. They've not been tested, but this technology is here. I'm flying through this because I want to give, I thought the best way of showing you how these work is that there's a free service called Cropsat, which does what all these things do, but does it for free. So I'm going to try and very quickly, in 2 minutes, show you how these work. So this is Cropsat. You don't need to pay anything. You don't need to log in. You don't need an account. It helps if you want to create one. Again, it doesn't cost anything. And what it does is it uses satellites to look at the variation in production across a given field. If you have your own maps of your own farm, you can load them up. It'll do it automatically. Or you can zoom in. I'm just going to randomly zoom into a field somewhere, and I'm going to say, I'm going to pick that field there. And so you say, okay, what you need to do is just digitize to map the field. Again, if you have the field mapped already, you can upload it. Say done. Then we ask it to download the satellite images. It only downloads a little bit that's necessary. Okay, and what we're looking at here is an image from January. It's a bit cloudy, so we're going to go back and look at, say, April of last year. Okay, April is a very good time to be looking at variation in your fields, whether it's a grassland or a winter crop, spring crops. You might want to wait till May. And what it does is it analyzes the data in the satellite to automatically measure the biomass or the green material in the field and show variations. So I click this button, and now we have a map just for this field that shows us the variation in that field that we couldn't see by the eye, but the satellite can pick it up. So dark green is high production, yellow is lower production. So this is valuable in itself. What I advise you to do is, if you're interested in doing this, you look at a field and look at a few images across the year. If you have a persistent area of high growth or a persistent area of low growth, you should go and investigate it. It could be soil compaction, it could be disease, it could be nutrients. If it's nutrients and you've got some sort of variable rate system, this map is downloadable, so you can put it into your system. So if we say we want these areas fertilized, the yellow areas fertilized, but the green areas not to be fertilized, so we can put in our rate of application. I'm just randomly picking numbers here for whatever fertilizer we want, and click next. And now what we have is a variable rate file for the application of these, and it can be downloaded into a system for any of these systems that are common in Irish farms, if you have that capability. If not, you can still say, okay, I can go out and I'm just going to fertilize this corner and that corner. And it doesn't have to be fertilization. If you think you've got a pest problem, you can change this so you're looking at liters per hectare of the biocide or the herbicide that you're applying. So that's really, really fast. It's a great free service. I think, you know, if you're interested in what's going on in your farm and whether there is an issue in variability, it's a great way for the cost of 20 minutes of your time and no money to go and look and see what these systems are capable of. And then, of course, you can either just use the data you've got or think about getting in some of the commercial services that are out there. Everything is going digital. Doesn't mean it's going to be high tech. for the user. The best services, as Anya said, are built around the user, so you don't need to know what's going on in the background. A lot of this is coming down the line regarding changes in the cap. A lot of these issues around, as Anya was saying, about remote verification, payment by results, validation remotely, all these things are coming down the line. So the farm is going to get more and more digital, and these systems are going to be used. But again, going back to the idea of data, with any of these systems, always look at the terms and conditions, always look at where your data is going, always look about the value of your data before you just willingly sign up, in just the same way that you would when you're buying online for something for the home. Thanks.
That's great, Stuart. Thanks a million for that brilliant presentation, and just fascinating there, the Cropsat app there. I hadn't even realised that was available. I didn't realise you were going to do a live demo of it as well, which is even better.
They always say you should never do that.
Exactly. And like you mentioned there that a lot of is coming down the line in terms of cap. What do you mean by that?
Well, a lot, as Anya intimated in a number of the projects there, a lot of the new ideas are that it won't be sort of on-farm assessments. It'll be continually assessing what's going on the farm to show that you're doing your farming in the way that you should do under cap, or the various schemes that are going to be in place. There'll be a lot of self-validation images being sent, and again, a lot of issues around pesticides and herbicides. A lot of that reporting is going to get more and more digital. You'll have to prove that you're only using it in the right way, at the right levels, in the right times. And I think even things like hedgerow protection, we can see these things more and more easily and quickly on the satellite. So it'll be continual assessment of the entire thing, rather than just waiting at the end of the year to get an inspection. And you mentioned as well, Stuart, about the carbon, monitoring the carbon on the farm. So even in hedgerows, obviously, are a fantastic habitat. They sequester carbon. There's a lot of stored carbon in hedgerows as well, which could be valuable maybe in future caps as well. Could you just allude to that as well? You discussed about, is it LiDAR technology that you can measure the carbon sequestration? Well, yeah, no. There's some very simple models. There's a project going on in Teagasc at the moment where we're trying to get better understanding of the carbon store in hedgerows. But at the very, very basic, all you need to know is the width and the height of your hedgerow, and you'll get an estimate of the stored carbon. If you get a better estimate of the height and width by, say, using a drone, just using normal cameras, so when the drone is flown, the images overlap, and those overlapped images can be put into a software that creates a 3D model. Again, that'll allow you to estimate the volume of the hedgerow and then get the carbon. So I think that 3D mapping, a lot of people are doing the survey by drone. Get the 3D map done as well, because it's a really good baseline going forward. So you can prove what's going on in the farm. Yeah, it's fascinating what's coming down the line, and even though that's where you can actually look at the field using that Cropsat and even identify where the nutrient is required, what areas are the dark green, or what areas are yellow. Really it's fascinating. You can learn so much by just looking at because you look at the image and you think, well, that looks it looks uniform, but because the satellites see in ways that we don't see, they can see smaller changes. And those smaller changes in loss of production, even on grasslands, can add up over the course of a year. You might be going from 10 tons to 9 tons. I mean, it makes a difference. I've seen a very exciting system there. It's called the Nevonex system. It was being developed by Bosch, and along with a number of partners. I think it was Syngenta and Amazon, and there was other machinery producers like Lemkin, and I think Yara was involved in it as well. And they're looking at, with the help of different machines and systems, they're able to share data and information easily. So we're kind of seeing really the movement of data and information to go into the cloud with systems and machines talking to each other, with recommendations going straight to the machine. So it really is fascinating what's coming down the line. Thanks very much for that, Stuart. And Peter, I see you started sharing your screen here already. And Peter is, just get it up here now. So Peter, you're there with us. How are you? You're just on mute there at the moment, Peter. If you can unmute yourself, please. Yeah, that's it.
Peter is a product development engineer who's worked in the energy monitoring and building controls industry for more than 25 years. He's a keen advocate for open source and open protocol technologies. As a small business owner, he understands the need to keep your business lean and embrace new technologies, which can help save money and reduce your carbon footprint, and a win for everyone. His company, GLAS Energy Technology, it's an Irish company that provides solutions for energy, water, and environmental monitoring. They design and produce hardware and software products for monitoring electricity, water, oil, gas, and other metered resources. So Peter, over to you. You have a short presentation and we'll take questions afterwards. And for anyone that's just joined, there is a Q&A function at the bottom. So we'll be taking those questions at the end for Stuart, for Anya, and for Peter. And we'll have a good conversation after Peter's talk. Over to you, Peter. Thank you.
Right. Thank you, Barry. So, as we're an Irish company, and my background has been in building management and environmental systems for more than 20 years. So I've been at this a while. We owned, and we have our own hardware and software products, and we also use third-party products to provide solutions for energy monitoring, environmental monitoring. The part of our system is the data logger. We have a couple of different versions of our own, the GT 1008 and 1032, that have different hardware capabilities. But basically, the data logger is designed to read from environmental monitoring meters and sensors and send the data to the heart of our system is the server for display and analysis. Where it's available, we use a local internet connection. For a lot of our installations, we use a 3G router to provide a completely independent data connection. The type of different scale from send the data to meter to sites for hundreds of meters. So the system, it's flexible, and that's important. And we support both wired and wireless connections to the meters and sensors.
Sorry, Peter. The line is very, very bad. And if you want to move your presentation on, you can move your presentation on. But yeah, we can't really see your slides moving along there either.
Okay, is that a bit better?
It is, yeah, that's better. Thank you.
Yeah. So the types of clients that we typically deal with have mainly been commercial and industrial, but we have had a number of agri sector clients, including meat processors, dairies, feed mills, tomato growers, fish farms, and poultry farms. And we've covered, say, schemes with apartment blocks from tens of meters to hundreds of meters. The type of things that can be measured really it covers a huge range. The meters cover things like water, oil, gas, heat, electricity, tallow in one instance, and common sensors for monitoring include things like temperature, relative humidity, carbon dioxide, dissolved oxygen. Anything that can be measured really can be logged if it has a suitable interface. We've used weather stations as well, so to cover things like wind, rain, sunshine levels, atmospheric pressure, soil moisture, leaf wetness, evapotranspiration. There's a lot of different things that you can do on that score. But as a minimum, in a lot of applications, the outside air temperature and relative humidity are important if you're trying to analyze data, because that gives you basically the environmental conditions at the time, so that you can see why the energy usage is varying, and better display analysis where it's better analyze what you're doing. And say linking the ventilation temperature settings to energy data shows you how things are performing, gives you a clearer picture. So the type of the been with our data loggers of a range. So meat processors, we have a number of those that are using and to make it the best use. Okay, so the types of the electricity usage, fuel usage, and water use. We deal with a complete understanding of what cost factors. The type of meters cover things, heat, electricity. We have covering a lot of anything that can be fixed. We've used weather pressure, soil moisture, that's for but the energy usage is varying. So the type of on project where we're using it, basically looking at the data through plant for the.
Sorry, Peter, the line is very bad there. If you just want to move along your presentation,
on poultry farm PV installation.
We're only getting every second word off you there, Peter.
Okay. So
you can move
the front end system. Yeah. So the front-end system provides the display and data capture for the data loggers, and we have our own system based around a program called Mango, but we also have fed many third-party systems, and in some instances people use the basic raw data with Excel for the lowest cost option. Most of our installations are fixed and are done on an ongoing basis, but we have done mobile installations for a number of applications. We did a project with the University of Limerick for Dairy Processing Technology Centre, where they were doing analysis of water usage on a number of dairies. So they used our data logger and a clamp-on ultrasonic meter, which they could move from site to site to do the analysis. And I suppose one of the things that they've seen from that is that approximately 2.5 litres of water are used for every 1 litre of milk processed on average, but that varies from over 5 litres down to less than 1 litre. So they're working on analysing what the factors are there. LED lighting has been used to check before and after for grant applications, so that the data has been fed into the SEAI as part of the application. One of the things we are looking at is that putting together a package which could be moved between farms to do short to medium term monitoring of different farms to make it more cost effective. And where we've used weather stations in the past, one of the things that can be done with that is to allow access to the data for multiple users, that one weather station in an area can provide local weather information to more than just the farm where it's located. Finally, one of the things that we've been asked about is the SSRH, and at the moment the SEAI are working on defining what will be required. But it should be borne in mind that on older installations and newer ones that are outside the SSRH, monitoring of the system for performance and tracking is still important, so that the system is kept working to optimum efficiency. Thank you for your time. Sorry about the audio quality, but if you have any questions.
That's great. Thanks very much for that, Peter. And it's very difficult to hear at the very start. We could hear you towards the end, all right. But that's always the challenge of doing the live webinar. Just in relation to the logging equipment, what type of cost would be associated with logging equipment? And say if a dairy farmer wanted to monitor the amount of electricity they're using for their bulk tank, for their cooler, is that a clip-on equipment that you could maybe move from one site to another?
Yes, that could be done, and that's, for example, for the application where we've our loggers have been used with LED lighting. That's exactly what they were doing, moving the logger in an enclosure from side to side. And you know, for that type of application, you're talking for the hardware somewhere in the region of maybe 12 to 1300, and the data costs for on an annual basis maybe in the region of 200 to 300 euro.
Okay. Okay, we have thanks for that, Peter, and we have our panelists back here again, Stuart and Áine. A couple of questions have come in for you, Áine. There, what is the email address to sign up or take part in the AgriSnap here in West Cork? As sure as many rural areas, Wi-Fi and phone coverage is not great. So.
Yeah, so I put the email address up on that question and answer, and is that the best place to share it, Barry? Maybe we can make it available afterwards as well.
Yeah, that's it. Or you can, we'll be putting your presentation up on the website afterwards, Áine, and we can maybe put it onto your presentation.
Yeah. Yeah, perfect. And just to make the point about the connectivity issues, I think this is a really good example of the need to talk with the end users at the start before we would develop any technology, because that was the #1 concern that came out of our initial work with farmers, was issues around connectivity. And this, I suppose, led to the addition then of a feature in the app itself to allow for offline photo capture. So that was really a feature that was prioritised in the second engineering release of that technology. So the AgriSnap app does work offline, and then it's a matter of, you know, when you go back to your house, if you have dial-up internet, that you'd be able to upload your photo that way. So you don't have to have 4G or 3G out in the field.
Okay, a question for you, Áine. There, is it possible to get funding to create software to put the sheep flock book online, similar to the cattle movement monitoring system?
Okay. I don't know, is that a budding entrepreneur who's suggesting that they're looking for funding, or are they wondering if it's something that the department might fund? But I think this is a good example for me. I think this is a really good example of understanding what farmers or farm advisors themselves want, you know, digitalize. And if this is a particular need that farmers or farm advisors would support, then I think that is what should be done. You know, technology developers and researchers should follow the needs of the farmers, and that's the whole idea of the design thinking approach that we would take for technology development. And so I'll certainly mark that down as an idea for future research projects.
Yeah, and it's probably the likes of maybe Enterprise Ireland that person should be really going to with if you have an idea or something like that and you were looking for funding for something like that. Maybe first of all you probably go to your local enterprise office, maybe followed up by maybe the likes of Enterprise Ireland. Stuart, there's a question there that we're in the middle of the 4th industrial revolution with digital technologies transforming whole sectors. Will the process continue to drive disruptive changes?
Well, yeah. I mean, it will, obviously. I mean, it's. But what we can't predict, obviously, is we don't know how that disruption will happen, and we don't know at what level of disruption will happen. Will it disrupt farm practice? Possibly less so, because most of the best services we've seen that most successful or embed themselves in existing farm practice. You're not asking the farmer to change what they're doing. You're just giving them the tools to make it quicker and easier and cheaper. So in that sense, it's maybe not going to impact the farm in that disruptive sense. It might disrupt further down the supply chain. So we've already seen how marts might get less used in the future. We could see direct selling of produce to restaurants and farm and consumers being made easy through digital technology. We could see tracking and tracing on the farm, selling the farm as an experience in terms of other enterprises, allowing bookings of holidays on farms and so on. So all that sort of thing will be the most disruptive. The day-to-day thing that the farmer is doing, I don't think it will change in the next 10 years. It'll just get, hopefully, it'll get easier and cheaper.
I often wondered what the terminology disruptive changes mean or meant, but I got a good explanation of it not so long ago, that there's good examples of, you see the likes of Ryanair, they've disrupted the whole travel industry and the way people book their flights, and changed it maybe from travel agencies. It disrupted that particular business. And the likes of Kodak, digital technology as well, that nobody's getting films printed out anymore, or so they're good examples of disruptive technology. So
I think COVID is more disruptive than any technology at the moment. I mean, and I think that's going to have more lasting changes on how we do work. I mean, we've already seen this push of COVID regenerating rural towns, possibly. So there's, I think that's going to be where the impact is felt in the next 5 years, not through the technology.
Yeah, the main opportunities for digitalization really seem to be in relation to improving, maybe, and possibly optimizing on-farm management and decision-making, Stuart.
Yeah, I think it's about information flow on the farm. I think keeping records, you only have to keep them once. Making them easier to share with the people who need to know these things. That's where the big gains are to be had. And so instead of having to spend 2 hours every Sunday night on the kitchen table doing the paperwork, you can be doing it as you're going about your farm business. Even simple technologies like a barcode reader on your iPhone, just to record purchases going in and out the farm. It makes life much more easy. So there's tiny little incremental changes that will just change how information flows in the farm, and then how we share that information.
I've heard it recently discussed, Stuart, that the idea of driving into a field and punching a few settings into a touchscreen and letting the computer take charge of key tractor and equipment controls, it might sound a little bit far-fetched, but agricultural driverless tractors, are they something that you see could be a thing of the future?
Well, they already exist across much of the world. I mean, in bigger settings, in the prairie style farming in America and Australia and so on. There's already remote operations in horticulture, little robots trundling up and down the glasshouses.
Yeah.
Again, I think where the big impact is going to be, I don't think a farmer is going to be buying a driverless tractor, but that driverless technology will make the tractors they're buying safer. So it's going to have a bigger impact on farm safety than farm production. Things like collision alerts, automatic movements, and so on. And that sort of thing is where that benefit will be felt in the short term.
A question here for you, Stuart. Are there any risks in sharing of data generated through machinery and chemical companies, for example, in relation to GDPR?
Yeah, I mean, Anya probably knows more about this side of it than I do, so she's probably a better place to answer.
Yeah,
but every time you've got data, there's always a problem.
Yeah, Anya, could you come in on that one maybe?
Yeah, I won't answer if there are risks. What I will say is there are definitely perceived risks. And what I mean by that is there is definitely concerns amongst different actors, including farmers, from the research we've carried out. Again, all the research we carry out is behavioural, and it's understanding what people think. And there are definitely perceived risks around what is happening to farmers' data. So some of the things that came up, if I can expand a little bit more on that idea of what are the concerns, there are certainly concerns at the basic level around who owns data, who has the right to benefit from data, what are the farmers' rights. Then also you move into data access and sharing, who has the right to access data. And that idea that if third parties, if you enter into a contract with a particular technology provider, if there is data if your data goes into a bigger data set, who has the right to access that as third parties come in? And that is a big concern for farmers. At the same time, data sharing is a very positive thing. Data sharing can allow for more technological development, allow for more positive outcomes, but it's how the whole process is governed that needs to be looked at. And who decides who gets to have access, and who decides who governs that whole area. So one of the things that we're doing within the Agri-Discrete project that I briefly mentioned during the presentation is looking at designing new business models and new data governance structures that would look at how data flows between data providers, I should say, and data consumers. And it's this idea of potentially creating business models or platforms that would allow for multi-sided or multi-directional data flow. And what that means in brief, is that the farmer has more control and more power to say, well, I do want my data shared with X party and I don't want my data shared with that party. And it's, again, using technology to actually enable them to make those decisions. So whether it's an online platform, an online trading market around data, this is where it's going. These are the ideas that need to be thought about. But what's most important is that you're grounding it in those principles of thinking around data ownership and data rights of the data owners. So it's a huge area to think about. And again, as I said, we're carrying workshops out on this all the time. So if anyone is interested to take part in that, and particularly data owners, as I would call them, farmers or forestry owners, really do want to involve people like that in those workshops and in those decisions that are being made around data governance.
That's great. Anya, another question that came in from you, and if any of you have any more questions, you can put them through the chat function there, please. Digital technologies are expected to have a number of both unseen and unknown impacts. Are there concerns that they will favour mostly intensive, large-scale farming systems rather than the smaller farmers?
Yeah, absolutely. This is, we done research around this about 2 years ago, and it was on this very topic of looking at the unintended consequences of technology development. And I always think that, going back to what you talked about earlier, the disruptive technologies, that sounds like a very dramatic term. And you think, oh, it's going to happen overnight. It doesn't happen overnight. Change comes over years, and it's so gradual that sometimes you don't see it. It's incremental change. But all of a sudden, we have these impacts that come in, and the best example is one that everyone knows around social media and the unintended consequences that have come from social media. You know, we've seen it in America, what's happened in the last year. Nobody would have predicted that social media had that power 10, 15 years ago. So it's around that idea of thinking, well, how is technology going to dramatically change what farms look like? It won't happen overnight. It could happen in 10 to 15 years. And some of the concerns that were raised in the study that we done with lots of different actors was around the idea, you know, will there be a loss of traditional skills and cultures? Will there be a loss of small farms? That was certainly one that came up. Would there be a situation where we've increased digital divides because of technology? Even issues around, you know, less interaction with animals. How does that impact the farmer-animal relationship if all of a sudden you're using a lot of remote or robotic technologies to monitor your animals? So there are a lot of those concerns that I think are being raised, and rightly being raised at this point early on, when we can consider them and do things to mitigate against these types of consequences. Certainly we would have heard also from, you know, other types of actors on the issue specifically of small farms, that there are technologies out there that also benefit small farms. So a lot of the time people tend to think of technology as one type of technology, but technology exists on a continuum. And as Stuart said, there are there's very tiny incremental changes that each farm can make, no matter what type of a farm it is. And I think, again, going back to COVID, that's proven it. You know, these what we call gateway technologies, whether it's as simple as an online mart or as simple as changing from a newspaper to an iPad, it's incremental changes that sort of increase the confidence of every farmer to try another technology, and they realize the benefits of that technology. So I might try that one. And it's that idea of incremental changes and introducing technologies to farmers in a graded way, and realizing that not all farmers are the same. So, you know, adapting your technologies and your approaches to embedding technologies based on the type of farmer.
Okay.
I'd add there, sorry, Barry, just to say that, you know, there's a lot of these technologies are hidden that will, and they do impact or improve things for every farmer. So, you know, weather forecasting is getting better. You know, every farmer can get benefit from that. Things like the beef genomics program, you know, it's driven by the big farmers, but it improves the national herd for everyone. So, I mean, there's a lot of this really high-tech stuff is hidden and is improving things for everyone.
Okay. Question for you, Peter. Peter, in relation to a poultry farmer in Monaghan, he's asking a question about monitoring equipment for ammonia levels in poultry houses. Do you have integrated systems, or can you discuss the integrated systems?
Yeah, the advantage, I suppose, of a system like ours that uses open protocols and open standards is that it can integrate with a lot of different types of sensors. So as long as the ammonia sensor has a suitable output, it can be fed into a system like ours. There are dedicated systems as well for poultry management that support ammonia, but as a separate monitoring thing, it can definitely be done.
Thanks for that, Peter. The line is still pretty difficult to hear you there on that line, Peter, but we got that anyway. Thank you. Question for you, Stuart. 3D printing as a digital technology. Are there any examples that you could see of where this could be relevant to farmers in the future, maybe in the design of printing of custom parts and small equipment?
I think 3D printing is one of these great examples where just something will emerge. You know, it won't be top driven. It'll be some farmer. 3D printers are very cheap now, 400 quid.
Can you explain what 3D printing is and how you could develop custom parts that relate to
3D printing is also called additive printing. So essentially, it's a system that prints out layers and layers and layers and layers of things that sit on top of each other. So by the time you've finished, you have your finished object. So it's creating it from nothing into the finished object. So instead of having a block of metal and chiseling out a piece of equipment, you make a piece of equipment from the bottom up in a 3D environment. Mostly plastics, but there are some metal systems, and there's some. They're even using 3D printing in food production at the moment, creating new ingredients. So yeah, there's going to be lots of examples. I think it's the idea of some farmer inventing a slightly better form of a crush or something. You know, those incremental changes. Think about how you use plastics on the farm. Think about how you can improve the thing you're using. Then get it done in a printed model. You can go. In fact, most libraries now have 3D printers, so you can go to the library and just talk to someone there and say, how do I design this? How do I print it?
And that would probably be more accessible to small farmers as well, because you have maybe a decentralization of the technology also. Yeah,
and also, I mean, I'm not going to trivialize it. You know, it's not like printing from a paper printer. You have to understand how 3D models are made on the computer, and then put that into a format the printer can use. So it's not a trivial to go from an idea to an object. You'll either need to train yourself up using free software like SketchUp, or go to an expert or a local authority in say the libraries, and they can help.
Okay. Another question here for Anya. I have to move screens here now. So yeah, Anya, digital isn't all positive, and is there sometimes too much?
Yeah, I mean, that's what we were talking about with so the unintended consequences are one thing that are hard to monitor for, but I suppose by having discussions, you hope that at least everyone is on the same page. If you're talking about digital technologies at an individual level and an individual farmer trying to understand whether or not to adopt them, I think that is where the support from, for example, farm advisors or from other farmers who have experiences of technology is hugely beneficial. And we do see that in our research as well. Like the influence of your social network, your social support is huge when it comes to these to deciding to use one of these technologies. I definitely think that can help at the individual level, is to have a talk to people who have experienced these technologies on their farms, go to demonstration days, go to demonstration farms, go to discussion groups and get a better sense of whether that technology can work for your farm or not, and have discussions with farm advisors or other people who would know about them. Yeah, about the idea of too much technology, I think that is, there will inevitably be more technology no matter what. As Stuart said, at a top-down level, it is going to increase digitalization. I think, monitoring is one issue. But it's about how you develop those technologies then. I'll go back to that if you develop it with the end user, not just with the end user in mind, but with the end user through this design thinking approach, then you hope to avoid any of the negative consequences or
Yeah,
And then,
and I'm guessing that there's going to be a need for a very transdisciplinary and maybe collaborative approach in the conceptualization and design of these type of technologies in the future. We're just running out of time there, Anya, and thanks for that. Guys, there's a lot of questions coming in there. One person has said there's lots of digital tools that are useful for the likes of the B World, for apiaries, for digital apiary management called B King. Another person says hands-free Hector is a system that they're using. The system of automated digital tools applied in arable farming. It was developed by researchers at Harper Adams University in the UK. Another person came in with saying that iFarming, it's a livestock integrated farm management system. It's a tool or management system used worldwide and developed specifically in intensive livestock farming in mind, such as poultry and pigs. Another one that came in here is AgriColus, decision support system that collects, analyzes and interprets data from forecast models and remote sensing. So there's lots more questions coming in. I have questions here about remote sensing, and maybe we discussed a lot of them, Stuart, here. Like we discussed robotics, we discussed 3D printing and data analytics, and social media and social networks were discussed as well. Do you just want to talk about the local and remote sensing there finally? And maybe
well, I mean, the Cropsat I showed you is all remote sensing. So if you're using a satellite, if you're using a drone, if you're using a camera phone like Anya's project, that's all remote sensing. It's getting information about something from a distance, and we all do it all the time. So I think the big changes that's happened in the last 5 years is we have many more satellites. So we get observations every day. We have satellites that can see through clouds, and now we have models of grass growth, like the MOST model in Moore Park, where we can take weather data, we can use the weather data to fill in the gaps between the observations, so now we can get more or less continuous coverage.
Yeah, and they provide much better knowledge for the farm and the agricultural ecosystem as well. Folks, that's great. Thank you very much for that, and lots of positive comments on your contributions here today. I suppose here we'll take one final question there. Where does Ireland compare internationally for the capturing and storing of data? Which other countries are doing well in this regard? Anya, would you wrap up with that one, please?
Yeah, gosh, in terms of world leaders, I'm not sure. Stuart, do you have any sense of what
yeah, I mean, we are certainly some of the horticultural companies are world leaders. In fact, some of them are almost now data companies that happen to grow strawberries. Some of the things like pasture base is a world leader in terms of capturing information that's happening on the farm. It's extremely valuable. One of the issues is in Ireland is because we've got so much of a grass base. It's only in the last 5 or 6 years that the technology companies have started looking at grass as a target. They didn't really consider it before now. So I think we're at the point of a real escalation of these technologies in Ireland.
Stuart, the adoption rates of precision agricultural technologies in Ireland, what are the barriers?
As Anya said, the SkillNet survey is the adoption of what you might call high-end precision agriculture is very low in Ireland, but it's low everywhere.
Yeah. And what are the barriers to that?
Cost, size, complexity, people not wanting to change, and in a lot of cases, badly made products that don't fit into how people use them.
Okay. Folks, here we have to leave it. I want to thank our 3 panelists today: Peter McShane from Energy Tech, from Stuart Green, my colleague in Teagasc based in Ashtown, and Anya Regan, also my colleague based in Teagasc in Athenry. If any of you want today's presentations or you want to see a recording of it, it will be available on teagasc.ie/farm business options. And also the full presentation has been recorded, and the presentations that were delivered will also be available also. So thank you to the 3 of you. Next week's Farm Business Options will feature the whole area of of social media as part of farm diversification. So from me, Barry Caslin, thank you very much, and we'll talk to you again next week. Bye-bye.
Bye-bye.